Not same. Okay, did you figure out? Oh, did you figure out the trick? No. Anybody? It's okay if you don't. I don't expect you to. Okay, this looks interesting.
And first one and the last curve which you which you predict is the same shape.
Same suit, yeah.
Yes.
Oh, really?
Yeah. Yeah. Now, why does there have to be two of the same suit?
Because we choose 5 cards, but there's 4 suit. We always had a 2 on one double.
Okay.
But I don't know why the number. How can you predict the number?
Ah. Okay. So this is a good lead-in for next week or Friday we talk about how the numbers work. But today I want to talk about the thing. It's really simple. So this is called the pigeonhole principle. And basically it says, it's kind of stupid, but it says like, it's actually very useful in hard problems. But it says, say you have like, it's like putting pigeons in holes, is what they say. But equivalent would be like, I have n items, so I have n of these, right?
Yes.
And then I have boxes that I want to put these items into, right?
Yes.
And let's say I have n minus 1 boxes. It says one box has to have 2 items. So it makes sense, right? Because the best you can do is you put them all in. So, okay. Well, n kaji.
Yes.
And n item. N minus 1 boxes. We put boxes in items. At least one box has to have 2. One of the boxes has to have at least 2.
Why n minus?
1. Okay, so if we have more items, okay, all right, here. All right, so, okay, how do I show you? I have, okay, let's say, okay, you have 2 pencil cases, right?
Yes.
Let's say you can only put 1 in the pencil case. Okay, if you have, so I have 3 pens, three pens. One of the, if we put them all in cases, one of them has to have at least 2 pens.
But one pen is not going to the box.
If they all go in, if we have to put them all in. 그 다 들어가면, like one of them has to have 2. Because if they all have 1, that's only n minus 1 items, and the last one is still there, and you have to put it in one of them. And so, in the card trick, the reason why there has to be, you have 5 cards, and you have 4 suits. So, you need 1 suit where 2 cards are the same suit. So, that's what you do with the first card and the last card. So, the first card, this tells me the suit, okay? So, after I see this, I know it's a diamond. And I also know another piece of information, but that's later. It matters which one you show first, but that has to do with this. And this, here's a hint. So I want you to think about this part for next week. These 3 have to do with the number. And in the order of these 3. The order of these 3 cards tells me the number.
Oh.
10 minus 3 is... No?
Wrong track. It matters like... Okay. Here's a big hint. It matters bigger or smaller. The order. So this is the biggest card first, then the smallest, then the middle part. That's what is important. The sequence. Okay? Now think about that for next week, because next week we will talk about that. The mic is awkward for me, so
Okay.
Okay, so this is called the pigeonhole principle. And there's like a lot of problems, like hard problems that you can do with it if you're clever. You can make a proof with it. Okay?
Pigeon is bird.
Yeah, okay, originally the problem is like they describe it as you put the bird in a hole. I don't know why. So they say it's like n pigeons and like, or it's like, n plus 1 pigeons and n holes. And the bird goes in the hole. It's weird, okay?
Okay.
It doesn't make any sense. I think this is more accurate. You're putting stuff in boxes. But this is just the name that you'll see in like a math class in English. So you need to know. Okay. Okay, so last time we have like, the dots, right?
Yes.
And you're saying like, oh, how can I pick 2 dots? Okay, so now I want you to consider that we have, these are people, right? Let's say we have 5 people, or 6 people, because it's easier. And you need to divide them into 3 groups of 2. How many ways can you do that? Okay, so here's a hint. One way that we can do this is like, it's the same as like, you pick the first 2, and then you pick the second 2, and then you pick the third 2. Oh, okay, let's try this one first. That one's a little bit harder. So let's try, first we need to divide them into 3 groups. No, that's too hard because that's a little bit, very basic, very basic. I want to put 2 lines anywhere. They can even be on the side. Okay, how many ways can I do that? How many combinations are there if I'm putting 2 lines and I have 6 dots? So this is the same problem as like, and also in this case, I'm saying that it's okay if it's like this. Okay, that's okay. But we'll get to difference later.
The stick can move anywhere.
Yeah, these can be anywhere. In the first one, we'll do different after this.
Is it possible that the lines are all is first or?
Yeah. We're not constraining anything to start. I'd change it to make it more difficult later.
Okay.
So one way to think about it is like the lines are one type like of thing, and then the dots are another. Like how many items do we have in total?
6.
No.
8.
8.
Ah.
Yeah.
What?
Oh, okay.
And the 2 lines are the same as each other. and the dots are all the same as each other.
You can solve the ways. How many ways? Jenny.
How did you write it in the common
okay.
notation? In the common notation.
8 factorial divides 6 factorial times 2 factorial.
Yeah. Okay, it's the same as like these are A and these are B. Okay? You get it?
Okay, yes.
Okay. Now we try another. And now we try we want to put them into two groups so that at least one is in each group. So this means that you can't have one on the outside. So this is no. You can't have this. And you can't have one here.
So line should be between about the ball.
Yeah, there has to be at least one ball. So it's like an example of something that would be okay is this would be okay. Or like, you could put them one here and then one here. Okay, so the way that I like to think about it is how many cases are there where like you have this kind of thing? How many cases? How many ways can this happen? How many ways can this happen? Okay, so first, all right, how many cases are there with this one on like the end if there's like no space?
It is including about the same thing?
So it's like anything where this is here, right, is bad. And how many other places are there for this guy?
6.
7, right? Because it can't be. Okay. So it's like you got the 2 there. 7. That's 7 bad ones, right? This is just breaking it down to like make it easy so you can like think it through, okay?
Okay.
Okay. Okay. Keep.
to plus the 7 time because the stick which was left side can be the same as right side too.
Yeah, so yeah, but you have to, the thing is that like that's the same, so you don't have to worry about it because it's exactly the same. So you just consider the sticks are identical. So it's like it doesn't matter which stick, so don't double count it. It's okay. You can do it.
We have to make the 3 group.
This is the same problem as making 3 groups where each group has at least 1 member.
Impossible way is 12 ways because it is not impossible like the same place like 5 place.
So yeah, so here is no good. So anything, it doesn't matter where you put the other one, it's no good, right? And then, alright, so then let's say that you have one on this end. Alright, well then anywhere you put this one is bad, but we already counted this one, right? We already counted that. So that's 6. And then anywhere where you put them 2 next to each other is bad. How many is that? 해보세요. is you can actually just count them because it's like not that many. If you know what I mean. Because okay, so there's like two bad like places here and here, right? So as we established, it's like 7 because this one, 1, 2, 3, 4, 5, 6, 7, all bad, right?
Oh, yes.
Now we've already counted the one where they're both on the sides. So then, all right. So 1, 2, 3, 4, 5, 6 are bad ones. And then you don't want them like that. How many is that? Yeah. Okay.
Wow. Why 짝대기 2개 is 5?
아,
And what is that?
나도 이럴 수 있는
Come on.
더하기인가?
But
아, 좋았어요.
what is the answer?
10.
Yeah.
10?
We need to minus that one.
Yeah. Yeah, it's 10. Oh, 18 doesn't equal 10. I shouldn't write that. That's bad. Don't do that. Okay, so 28. Right? Is it 28? I don't know. I never computed it. I literally just had like, yeah, I think it is. It is because it's 7 times 8 is 52.
Yes.
Okay. Now we're gonna do something else. So now we want to make okay, I'm waiting for everyone to finish. Okay. And what is okay. Now we want to make 3 groups
Yes.
of, okay, let's just do 3 groups of 2 first, from 6 people.
Exactly 2 people.
Exactly 2. First we're going to do exactly 2 people in each group. Yeah, this is assuming people are different, so it's all different. But, yeah. So this is like essentially the same as like what we did last week, but it's like the difference is that in this case the people are considered different. So it's like it's not exactly the same because they're different. The people are different from each other. I literally am such an idiot. Okay.
Six. Answer is
Hold on. Okay. Three groups of 2 people from 6 people.
oh. And to the minus 3 people.
아, 노숙.
Okay. So we've got like, in this case, the people are different. We have people who are A, B, C, D, E, F. Okay, let's form one group. How many ways can we pick the first group? How many ways can we pick 2 cards from a deck? How many ways can we pick 2 people from 6 people? He always does this. Why does he do? I don't.
16.
I think it's 15. All right, we formed one group. How many people do we have left?
It's 4.
Okay, how many ways can we form another group of 2?
6.
Yes. Yes, but. Okay. And how many ways can we make? And then the other 2 people, how do we pick the last group of 2 people?
Same.
Yeah, there's only 2 people left. So it would be the same as writing. Choosing 2 people from 2. Okay? So, how many ways can we make them?
2.
Mm-hmm.
8 and 90.
Yeah. But, you know, you guys, it's okay for me. I don't care if you write this. You can literally just write that as your answer. And I don't care. Because I know that's easier, actually. Because no one cares what the actual number is. Okay? Do you get it? You're just picking 2 things. You're like, alright. Okay. So we've got that. Same items, different items. Right? Alright. Alright. Now, let's see. Should I give something harder? It's okay. Okay. So, now let's give a similar problem because everyone was a little struggling with that. So, we have 7 people. And I want to make, okay, no, something easier because 8 people, 4 teams of 2. You guys need to do this yourself. You can do it.
solving way is same as before.
Similar. It's the same way that you solve it. Oh, and then I have big next question.
We have to solve the number.
No. Yeah, he's good. You don't need to solve it. This is good. Just multiply together.
Really?
Yeah. 괜찮아요.
Why use the formula in this problem? Why we use this?
What does that formula mean?
Yes.
What does that mean? What is the significance of that? What are we doing when we're using the formula? Why are we using that? Okay, we make teams with 2 people. Team 1. Well, we need 2 people to go on team 1. Who goes on team 1? We need to pick 2 of them. How many ways can we pick 2 of them?